Good afternoon. Well, my presentation is about some examples I've been collecting from working around the globe in some immediate solutions to climate change that doesn't really belong on the lab, but on the kitchen table, men and women that react immediately to the challenge of climate change and do something about it. On that map, we can see how the countries, actually the rest of the world below the political equator that was coined by Teddy Cruz, there's the wealth of the world in terms of food, in terms of biodiversity, but their contribution to climate change is minimum. But they learn pretty fast about adapting to the challenge of climate change. This is a place called the Bambuceria El Capricho in Brazil. Farmers that were displaced by the fact that sugar cane was no longer a good product for them, the price of the sugar came down. Climate change made drastic changes on Brazil. So they, instead of continuing the road of degradation, they planted bamboo and they started building an industry based on bamboo, right almost immediately. By themselves, not really. They also use science provided by scientists, gave them the opportunity to learn very quickly. So they were not only building some amazing products, now it's blinking, that you can find in boutiques around the world, like that hanger, that it's very elegant. But also using the bagasse left behind, instead of turning that into trash, as packaging for those elegant hangers. So they replenish their economy by reacting quite fast to the challenge. This is a mycorrhizal fungi that exists almost everywhere. If you don't know how to use it, you may just ignore it. But people in Colombia learn about the possibilities of using it to replenish the forest. And therefore, they're starting using the mycorrhizal to replenish the productivity of the land. And again, the science connection to that was understood by farmers who then started planting in arid lands, acidic lands, these tiny trees that eventually became a forest and all the undergrowth that started producing resin to support their economies. So where there was a problem of misery, well, there's not now abundance, but they at least generate income. This is another beautiful example. It's climate change affecting waterways almost around the globe by producing water hyacinth, which is destroying the waterways. It's taking all these nutrients and all the water, but produces nothing. It's a plague. You see these women trying to control it. There were programs sponsored by the government trying to clean the water hyacinth just to make it worse, because once you break it, it spreads even more. Well, these women, led by Dr. Margaret Tawira, started using it, the water hyacinth, as the basis to produce fungi. In Africa, they were not accustomed to the delicacy of eating mushrooms. So she went out, house by house, convinced the people that it was a good product. They found out that that food was not just good for them, but also to replenish their environment by using all the trash produced by the water hyacinth. They have this substrate rich in nutrients that only fungi can use, and eventually became independent. I've been associated closely to the mushroom production factories. And they're clean, they're sophisticated, they're complex. Well, these women are producing pretty high quality products on those shacks. Is there a way to fix this? Well, that's all right. So how's the process of turning trash, of turning waste into something useful and something that actually helps with climate change? So we have science serving society. And by doing that, we serve the society right away. We put in their hands the math, the biology, the chemistry that communities need to understand, and they do understand really fast how to use it. They've been able to turn those resources into the response to their emergency. And we can see those emergencies around the world. We can see how they, when there's a climate change impact, they lose their property, they lose their income, they can lose a limb on a storm. They lose everything, but they're changing, they're adapting. These women that once they get it, they go out and they don't wait for decision makers or politicians. They go out and do something about it. They create a type of decision-making process fueled by science, but also fueled by their need to react immediately, because they cannot wait for planners. They cannot wait for universities to react. And this is the case, Teddy Cruz already referred to it, of the San Diego-Tijuana region. And that map shows the hydrology, which in the past was good. Water and sediment was needed to maintain the Tijuana River estuary. Nowadays, what it flows is trash. Every time it rains, hundreds of thousands of trash, tons of trash, crosses the border into San Diego in a kind of a Montezuma revenge, because all this trash initially came from San Diego. So we've seen the transformation of the landscape from this, which is kind of a pristine coastal canyon, to something like this, impacted by a storm. See, these shacks, these houses, are perhaps the only product of the income they get, and get destroyed. Their houses get destroyed. Their property get destroyed. Their social networks get destroyed. Their ability to go to work, to communicate, get destroyed with these climate change impacts. This is a map that shows on the left water availability, and on the right, sewer availability on one of these coastal canyons. So when there's water, there's sewer, there's wastewater. Is there a way to deal with something like that? Otherwise, that sewer flows into the Pacific Ocean. Well, the way was go back to the science and explain to people a way to deal with it. So from these public meetings with the neighbors, with public meetings with officials, with scientists rethinking the opportunities, back to the city to promote changes in the legislation, and then finally back to the community, we were able to produce this kind of process. In 1999, we did a study of the canyon that then in 2005, thanks to a grant I got from the California Coastal Conservancy, transformed into an urban master plan for that little area. In 2007, a public law was published, adopting all the science, basically, and to create city ordinances. And then in 2011, another public law allowed us to promote more of the same. But is it possible for people to understand the science and the policies and the language of the city ordinances? It's really, really hard. So we produced a comic book that explained all the steps of the scientific process then how the public law works and how to implement it. And these people with this type of material started doing amazing things. Like, for example, they started producing pervious pavers. And it's not just pervious paver for itself. This material controls sediment, harvests water. If wastewater flows on those pervious pavers, the nutrients get captured, and that produces topsoil that feeds into the ecosystem. Not just that, they were able to sell their product to the government. So that's their first check. So they have now income. They learn the science of it. And they replace the public works department in their community because they never get there. And now they're transforming their environment. Plastic bottles, they're in the environment by the hundreds of thousands. So this group of women went out and started building structures made out of this trash. And from all that rubble of trash coming basically from San Diego, they started building other structures to improve their community. And if you can see, these materials are very durable. They're designed to last. They're strong. So it's just a matter of understanding how to use them appropriately. So the lessons we learn are that we can trust the community and learn from their rapid reactions into creating and documenting those reactions so we can produce the new type of science, a new type of city ordinances, a new type of decision-making process that will allow them and us to abate the climate change impacts. They can adapt faster than otherwise our beautiful climate adaptation plans. It takes a long time to implement processes, political processes particularly, but it takes no time to engage the community, provide some scientific information in the form that they can understand, and then we can have some very practical and elegant solutions.